let's go.
Audio Jungle.
Yeah. I really got the feeling today
Audio Jungle.
that everything is going my way. Now this is what I'm talking about.
Audio Jungle.
Every time I see your smile, it makes me shout. Let's go!
Audio Jungle.
Let's go! Nothing's gonna stop us today.
Audio Jungle.
Get on the bus or get out the way. We're cruising with the radio on.
Audio Jungle.
So turn it up to 10. Here comes our favorite song. Let's go!
Audio Jungle.
Let's go! Let's go!
Audio Jungle.
Let's go!
Welcome, it's another Friday, and as you know it, every Friday is Functions Friday. Today I'm coming to you with another episode of Functions Friday. Yours truly, Samuel Adrani, and hopefully I'm going to get some knowledge to you today. We can learn something new, we can have fun, and we can write some code. So today on Functions Friday, what am I going to talk about? So last week I gave you a glimpse of what functions can do. We created some demo applications on functions. We created a very basic hello world function. We created a function that actually calls out your name when you pass your name into it. And then we created a function, we just modified the function that allows you, that sends you a random number when you call it. That URL is still active. You can go play around. I'll send show notes in the feed. So today I'm going to take a step back and take you through what functions are, what role they play, what the Microsoft Azure Function Framework gives you. I just want us to understand. I just want us to understand what functions are and more, from a theory perspective, so you can appreciate and understand that. This is going to be, this is more or less like a webinar on functions. So I'm going to tell you a lot more about it, and then in subsequent feeds, all the things I'm going to talk about in today's webinar, I will tell you about. I would actually tell you about it, and I'll actually demonstrate it for you in subsequent editions or episodes. Okay, so without much ado, I'm going to get right into it. Now, just remember that if you have any questions, you can send me a message on all the platforms you're watching me on. So if you're watching me on YouTube, you can send me a message. I will get and respond to that. You can also tweet at me at sadrani, which is my Twitter handle, or you can send me a message on um, Facebook. If you're watching me from Facebook, you can also send me a message from Facebook, and I will duly respond. So without much ado, let's get right into it. So serverless functions or serverless with Azure Functions. So I'm going to demystify it, give you a glimpse of it, explain a few things to you, and then hopefully we can, get it started. So who am I? Good question. So my name is Samuel Adrani. I'm a senior software engineer at Andela currently. I have about 15 years of combined technical experience. Um, well, pretty much, all my life till now, things I have done. I have a few accolades, so to speak. I have a few accolades, so to speak. So, MCT, MCP, MCSD, you name it. Some of them, I'm not even talking about now. I have Alexa skills developed, 7 of them plus, more coming up. I'm passionate about cloud, IoT, AI, ML, open source stuff. I love graphics as well, so most of the graphics you see on this show, I did it. I just love to play around with stuff, but Primarily, I like to try new things. I like to try new software, new technology, and see how I can put them together, to make my life very easy. I like to do that a lot. So, the agenda for the webinar today, we're going to be talking about the evolution of application platforms, where we've come from to make functions very viable for us. I'll talk about serverless applications. I'll talk about Azure functions, and then I'll talk about some scenarios. I try to keep Fridays and Tuesdays to between 15 to 20 minutes, very brief and succinct, so that we don't go beyond it. But this is more like a webinar, so I'll try to go through the agenda. I will skip the demo part because we're going to see a lot more demos and hands-on in subsequent sessions. But if I am done with the information and there's time, I'll go back to what we did last week, and then I can have people try to hit it again or have people connect with it and have fun with the functions. So let's get right into it. So functions, right? Now let's look at the evolution of application platforms. Now for everything there's a cool story. Now before we get into it, let me tell you something very small, kind of like a story about serverless or functions or applications. So remember those days when you had to deploy your application, you're building a solution and you had to deploy the application? You had a lot of things to think about. One of them was I need to buy my own hardware or software. I need to, deal with data centers. Like, do I want to host it in data centers, cloud set? What you need to think about all these things. You have to deal with a multiple like number of questions. Like, how many servers do I need? What is the physical security for the place I'm hosting? What if the hardware fails? How often should I be patching the hardware? Um, when do I have to back up? And if I'm backing up, do I have enough space to continue backing up? These are valid questions. A lot of questions you ask yourself when you start to deploy your own solution. You build it, you look for the server, and you host it. That is where we've come from, all these years. Now, this is how we have evolved. We started from on premise, where, you build your solution, you think of on-premise servers, you package them, and you host them. Okay, now this gave us these questions. How many servers do I need? How much are they going to cost? Backup, electricity, generator, patches, all these questions. Then we moved off from these things, having to ask ourselves all these questions. What media should I use? What is the right size? How do I develop? All these questions were, if you were an application developer then, you had to be thinking of all these questions at the same time thinking of how to make the application very useful. So you had a lot going on for you. Then we moved to infrastructure as a service, where we said, okay, hey, here comes the cloud. Why don't you leave the provisioning of the service, to us? Okay, we'll handle that for you. We'll handle the servers and all that for you. But then you still had questions. Before you go infrastructure as a service, you're thinking, okay, what is the right size of server do I need to provision with that provider? How can I increase, server utilization? How many servers do I need? So even with infrastructure as a service, you still have some questions to answer. All right, this still mm, we're not feeling much comfortable because for infrastructure as a service, it is literally here are VMs for you in the cloud, and you determine how many VMs you want. There's some level of responsibility on your side as a developer. So we moved from infrastructure and we went to platform as a service. Okay, and like, okay, hooray, now we're giving you a platform. You don't need to worry about provisioning the servers, the patches, the backup. We'll take care of that for you. And then we're like, oh, phew, that was cool. But then you still had questions. What is the right size of server? How can I increase the server utilization? How many do I need? You still had, you know questions. We still had questions on, what service do I need? Is it a node? Is it IIS? You still have some questions, to answer. And then, to make our life very easy, came something called the serverless platform. And for serverless, which we term to be the next generation of applications, all we need to do is how do I architect my solution to run very well on this serverless platform? All right. Now, it might be the latest talk of town. Serverless or microservices might be the talk of town on how to implement solutions. But then I want to let you know that it's not a total lack of servers. When we say serverless, it doesn't mean that there are no servers behind. It just means that there are servers. However, all that abstraction, everything is, taken care of for you. Scaling, patching, pretty much everything. All you need to worry about is write your business logic and let your business logic run. Now, we're going to see pretty soon some of the benefits of running serverless. So, serverless basically, all right, gives you a few benefits. However, it is the abstraction, okay, of servers and infrastructure and configuration, okay, of operating systems. Now, so pretty much it's just the infrastructure is there, but we are hiding all that complexity from you. All we want you to worry about is developing your application. That is what serverless literally means. So it's an abstraction of servers. That means all the things are hidden from you. So your compute is fully managed, operating systems, um, all that, you know, bits and pieces, both and out on the servers are abstracted from you, and you just have to concentrate on your code or your logic. Then it's what we call event driven. Okay, it's event driven scale, which means that unlike traditional applications where you needed to worry about scaling, out or scaling up. That is either you're adding more memory, more CPU and all that, or you're adding more servers onto it. What happens with serverless architecture is that it's event driven scale, which means that as your event is growing or your requirements are growing, your environment or the platform is scaling with you as well. So you get that benefit, as well. Then it's sub-second billing, which means that unlike traditional or conventional ways of hosting applications where you're paying for the server whether someone calls your endpoint or not, or whether someone goes to your website or not, you are paying a fixed monthly charge. Serverless platforms architectures don't go that way. You only build for what you consume, in the sense that you only build from when your code executes. So if I have a piece of code written using serverless architecture, I'm only billed anytime that piece of code runs. So if for the whole month that piece of code has not been run, I don't pay anything for it. That is some of the features of serverless. Now, again, what benefits do we have? Obviously, micro pricing. It means that, yeah, I don't get to pay a lot more if my services are not being called or my logic is not being called. I'm paying less. Ease of scale. Yeah, the platform is going to scale up when demand goes high. So which means that when people are calling my logic or my endpoint a lot of times, it's going to scale for me. I don't need to worry about that. And then I have less to manage, which means that I don't need to worry about OS patches, all these, technicalities. No, I concentrate on running my code. That is just what I need to do. Now, let me give you a fact file. Now, Forbes said that actually 30% of all servers are sitting comatose, according to research. Well, what does that mean? It means that if you're running servers or virtual server infrastructures, 90% of your computing output is wasted. It's not being used. It's just sitting idle, because typically servers only utilize 5 to 15% of their capacity. So what's the point in having, hosting or having servers run huge infrastructures when you 90% of the time is being wasted? So it's time to rethink, serverless. Now, let's come to Azure services that actually support serverless. Don't forget, this channel we're talking about Microsoft Azure. That's what we're primarily talking about. And today's serverless, I'm actually going to drill down specifically to Azure Functions. So these are the number of this is just a few of the many serverless offerings on Microsoft. There's a Functions, there's a Logic App, which is the event grid. So Functions is a serverless compute. Logic App is a serverless workflow, UI based or declarative. Event Grid is the serverless event management or event triggering in Microsoft Azure. And then there are varying of other serverless options: storage, security, IoT, analytics, intelligence, and databases. All these things form the bedrock of the numerous Azure services that are serverless oriented in the Azure cloud. So, since we are all about Azure, let's talk about Azure Functions. Yes, you might call it Azure, you might call it Azure, you might call it Azure. Any way it sounds to you. So Azure Functions is basically serverless compute service that enables you to run code on demand without having to explicitly provision or manage infrastructure. Again, like I mentioned, so everything about the provisioning is handled for you in the backend. It's handled for you in the backend. So you can primarily run your code and just sit, chill pill, take some beer or coffee, and see your application run. That's what Azure Functions, functions are. So I'm going to walk you through some processes or the core characteristics of Azure Functions. So Azure Functions are primarily um, triggered based on events. Okay, so you're reacting to timers, you're reacting to HTTP or events from your favorite Azure service, or someone clicks a button, or someone does something, or if an event happening somewhere. Your Azure functions are triggered. Now, these things trigger your Azure functions, and here Azure functions are basically just pieces of code you write. Pieces of code you can write in C Sharp, pieces of code you can actually write in Node.js, pieces of code you are writing in Java or Python. These are just pieces of code you write, okay, that actually um, enable you to react to the events that were generated. Now, after you react to the event, you can decide to output them to different places. It could be storing a request into a database. It could be sending a push notification to someone. It could be sending an SMS, sending an email, orchestrating something else. And I promise you that we're going to see some really, really, really cool things on this channel. We're going to see how we can trigger, IoT sensors to call Azure functions, to do stuff in our homes, to send alerts to, trust me, you have fun. So this is a very basic workflow of Azure functions. So let's talk more into a bit detail into what functions offer. Like I mentioned, uh, in terms of the platform, we have developer tooling that allows you to actually build functions. So we're looking at developer tooling, we're looking at the bindings, we're looking at debugging, we're looking at running open source tools. So all these platforms are there for you to build functions. In terms of development, you can use IDEs that are supported, like Visual Studio, Visual Studio Code. All these IDEs are supported for you actually to use. So we're going to see these as well. Then also you have Visual Debug History, which allows you to debug them. You can actually develop functions locally as well. And then you can have continuous integration and continuous deployment or delivery also using Azure Functions and monitoring. Now, in subsequent episodes on this channel, I'm going to show you how to do all these things. As mentioned in the previous slides, Azure Functions work with bindings, triggers. Okay, so bindings are, I mentioned in last week's episode, the bindings are more or less like variables, um, input variables and output variables. Now, some of the input variables or bindings are the triggers that actually cause functions or Azure functions to wake up or trigger. So as of now, this is just a few of the many bindings there are. So blob storage, Azure Cosmos DB, Event Hub, external file, HTTP webhooks, mobile apps. These are just a few of it. Now, the cool thing is that if you don't have a particular binding, you can create your own. An example would be, let's say here in Ghana, most of us use Hoptel for SMS notification. We realize that we have Twilio, but we don't have Hoptel. So you can actually write your own Hoptel SMS binding that you can use in function. And I'll show you how to create that on this channel. Now, triggers are what wakes or what actually pushes functions to run. And like I mentioned, they're also just bindings. So Blob, Cosmos, Time, Generic, HTTP are all bindings you can use. Now, the cool thing about Azure Functions, like I mentioned, and the serverless platform is that now these have a different pricing module. I think they are introducing what they call the premium pricing. It's still in preview right now, but these are the two main ones. Consumption plan. So consumption plan is the default pricing module, which means you only build for when your function runs or when your piece of code runs. Then the app service plan version is when you actually decide to provision an actual a platform as a service server. So let's say for instance I have a few websites running already in Azure and I have an app service plan for it. I can decide to add my functions to that app service and that also run. Now another thing I also want to talk about is that um, there are two versions of the Azure Functions runtime. Version 1, which is the initial one that was developed, is actually running on .NET Framework. Now, that means that it's not cross-platform. It only runs on the on the Windows platform. So even if you are hosting it in Azure, you can only host it on a Windows VM. Now, the version 2, which was actually written in .NET Core, and .NET Core means is that it's standard, it's cross-platform, which means it can run on almost all platforms, on Linux, on iOS, and then on Windows. Now, there are a lot of toolings that allow you to create this, and we'll see them subsequently. Now, let's see the supported languages. So someone will ask, well, I'm not a C Sharp person, it's a Microsoft thing. I'm here to tell you today that Microsoft loves open source. You can be a Java developer, Python developer, PHP, TypeScript. You should be able to create this. Now, as of today, the languages that are generally available, okay, in version 1 and version 2, at the time of this recording, C Sharp is, JavaScript, F Sharp, Java is. Currently, there are some experimental ones going Python, PHP, TypeScript. So, depending on the language you are very conversant with or you are fluent in, there are options for you to create your functions. Then let's talk about tooling. Now, last week we saw how to create it in Azure Portal. We also saw how to create it in Visual Studio Code. Um, in subsequent editions, I'll be mixing and matching. I'll create it using Azure CLI and then Visual Studio itself. If you're also a Java person, you can use a Java or Maven, Eclipse, and any other thing you want to. And then also there's something called Azure Functions Call to CLI. That's what we're using last week to create it from the command prompt. Now, there's something I want to be explicit about. When you create functions in the portal, modify them in the portal. Don't bring them locally to modify. There is some inconsistency going on there. So I personally prefer to build all my functions locally so I can have control and do my DevOps and CI/CD and then push them in the cloud. So that's just my own preference, but you can do whichever works well for you. So anything that is experimental, as you can see, Python, PHP is not supported and might be abandoned. It's just like they are trying it out. If it makes it, it will be in preview and then it will move to general availability. But as of today, C Sharp, JavaScript, Java are all generally available in even version 2 of functions. Now, let's look at some scenarios. Now, scenarios that you might want, you might use Azure Functions for. So, as you can see now, we have real-time stream processing, which is one very simple scenario that we have here. So in this, you can see that we have some information coming from, let's say, millions and millions of devices, like a factory. You have sensors in your factory devices, what do you call it, timing belts, different things. Now you can use stream analytics to ingest all this data, and then as the data is coming in, you can use Azure Functions to transform the data. Maybe the data is coming in a particular format, in a particular proprietary format. You can use functions to trim, transform it, kind of like an ETL, extract, transform, and load. You can use that to restructure the data and store it in the database. Now, an example another example is time-based processing. So you can say that every 15 minutes, I want you to, in this case, find and clean invalid data in my database and update them. Now, you could use this for different scenarios. You could say that, okay, every 15 minutes, I want you to pull my Twitter feed and see what's trending. Okay, or you can say that, oh, every 15 minutes, I want to check if there's a new, let's say, stock update. You can use that, also to do this. Then we can also talk about mobile or IoT web backends. So you can actually say that when some activity or action happens on a mobile phone, you can actually call Azure Functions to to respond to that. That could be storing an image. So I can say that anytime I take a picture with my phone, immediately that should be sent to an Azure Functions that should store the picture, in a database, or actually resize the picture or tweet that picture for me. You can use functions to also, do that. And the last example I'll give is real-time bot messaging. So let's say if you want to build an Alexa skill or Cortana or even Siri, you want to build, a conversational bot. What can happen is that you can use Azure Functions to trigger anytime there's actually a query or a question from the bot to the function. You can actually trigger that as well. So these are just a few examples of how you can use Azure Functions to do crazy things and interesting things that we'll see on the slide. So how do we deploy and monitor? Like I mentioned, you can deploy using Visual Studio Code. There's a function CLI. There's a Visual Studio Team Services. There is the Azure Resource Manager. And then Maven Jenkins, different deployment tools. In terms of monitoring, You can use Azure Application Insight, you can use Functions Load, Azure Monitor, or you can be creative and implement your own kind of like login. But why reinvent the wheel when these login features are available for you, to use? Now, let me touch on some unique thing about Azure Functions. Now, one unique feature is proxies. Now, if you've built APIs in the past, you know how cumbersome it is to create multiple routes and all that. Now, Azure Function proxies allow you to create serverless APIs, basically with functions. So, if I want to create a mock or test API, I can create multiple routes. For instance, we'll see that in next week's episode, where I'll create 3 different routes. It's basically the same endpoint, but 3 different routes that allows you to call different functions within my app service plan. So this allows you to, route, okay, create a single API service for clients, open API support. You can actually, create your own local development with that, and it's generally available and has all the benefits of serverless. So which means that if you create a serverless API, you are only billed when that API is called. Saves you money, saves you time. Again, remember that if you don't have a proper architecture, there is a myth I want to debunk when it comes to serverless architectures or when it comes to cloud architectures. Yes, cloud makes things easy, but if you don't properly architect your solution, cloud could be an expensive migration for you. So make sure you're getting the right expertise, you're getting the right consultants to help you to architect your solution properly before you move them to the cloud. Now, with that said, let's move on to some best practices. Now, one thing you should plan, understand to do is that now function should do just one thing. So, which means that you don't need to create a function that is checking the stock, is adding the item to chart, is creating the user account, is sending an email. No, that's just an overkill because remember that functions have a time span for which they can run. I think it's about 5 minutes, but you can push to 10 minutes maximum. So your code should be able to run within this period. If you don't want, if this is not a good case for you, you can actually move to an app service plan or the premium plan, and then you can actually scale this out. But make sure your functions are doing one and one thing only. Now, functions should be stateless. Stateless in the sense that functions do not need to understand, what happened before. They just pretty much are going to execute when you call them. Now, if you need to do something that requires statefulness, then you're going to use something called durable functions. I'll talk about that, next in subsequent episode. It's a complete thing on its own. I'll show you how to do that. That is able to store state between function calls. Now, function should be idempotent or idempotent, as we say it. It says that irrespective of the load or irrespective of the number of times you call the function, it should give you the same output. Period. It should just give you the same output. Whether you call it a million times, a billion times, a gazillion times, it should give you the same output. That is what idempotent means. Now, function should finish quickly as possible. Like I was mentioning that it just takes a finite time for functions to run. Okay, so I make sure one thing idempotent stateless, and then you're making sure your code is running quickly. If the code you're going to run within functions is actually lengthy, I will suggest you move it to what we call the worker process or background processes. I'll show you how to do that as the scenarios present itself. Now, there is one thing you need to know when it comes to functions, that it causes a disruption. You need adaptation. You have to rethink. You know, there has to be a paradigm shift. Now, these are just things that tell you or gives us an insight into what it takes to move into functions or serverless. Now, think about this. So, instead of doing pooling or polling, now, if you don't know what pooling is or polling is, now, conventionally when you write applications, okay, and you want some form of real-time update, apart from using WebSocket or SignalR, you have a piece of code that is always calling an endpoint. Has something happened? Has something happened? Has something happened? So you're continuously doing that. But if you think about triggers instead of pooling, you're saying that I'm going to do something when an event happens in my application. Think that way. Now, instead of thinking SDKs, and for those who don't know what SDK is, it's a software development kit. Now, thinking SDK, now, if someone is on the stream right now and has done SDK implementation, you need to get your secret keys, your private keys, you need to get all these keys. You need to now go and look for the client library, whether you're using JavaScript, C Sharp, whatever it is. You need to go and look for the client libraries. You need to go into the code and then write, the connection to that SDK, passing the parameters. It's a lot of work. But think bindings, think extensions, think connectors. Azure has several connectors pre-made. So if you want to connect to a database, you just include that binding. If you want to send an SMS, just include that binding. All the hard work has been abstracted and to make your life very easy. Instead of thinking route and web apps or server, think single functions. So let your functions do the specific. So if you're running something like an e-commerce website, you can have multiple functions that create a user or create an account, works, one that sends payment, one that adds, or modifies the cart. You can have, multiple functions to do crazy things. Now think about, instead of writing large functional tests against your app which has thousands of functions, think of unit testing. Because your app, or sorry, your function is doing one thing, you can test that function effectively. And make sure, think of, instead of building and deploying servers, think of collection of functions, or what we call microservices. You have bits and pieces of functions working together. Now I leave you with a very famous quote which came from a friend of mine, Bright Smith, who went for one of the conferences in Seattle. He said that don't throw hardware at software problems. Don't throw hardware at software problems. Now, what we're saying is that you can have, you can throw beefy servers, CPU, memory, a lot of resources, when actually you just need to write your software to be very effective, to be small footprint, and to be very scalable. It saves you a lot of money and time. With that said, if you have any questions, you can ask me in either on Twitter, Facebook, or the feed you're watching me from. Um, that brings us to the end of today's theoretical overview. But I'm going to go over, I'm going to show you what we did last week, so that we can actually, how do I call it? We can actually play around with the functions we created. So the function we created last week was basically a simple function that allows you to pass your name, okay, and then it generates a random number for you. Now I mentioned that I am actually building upon a solution that you understand in the end. I'm going to be giving away some prizes, and this will be some of the functions I'll use. If you call a particular endpoint, setting number will be the winning number. So if you get the winning number, hey, you know, um, congratulations to you. That's gonna work. So I'm going to take you to the functions we created last week, and then we'll go over it again, and then you can hit at it, and then let me know if you hit it and you get a result. Just tweet it back to me. Let's see how that works. So let's flip back here, and then let's bring this in view. Uh, So let me go to my resources, and this is the Azure portal. And as you can see, guys, Microsoft has done some cool update. Really, 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 really cool update. Actually, let me flip to this camera. They've done some really, really, really cool updates. So, like, I can see here, the icons have got uh, some love. The icons have got some love. Let's see. Okay, so let's open our functions. Our functions. And here we go. Okay, so I'm going to I'm going to open the token generator function, since that is the one that we deployed, which is anonymous. And yep, tomorrow I'm speaking at the Global 365 Bootcamp, the Global Microsoft 365 Bootcamp at the Mövenpick Ambassador Hotel. I'll be speaking on actionable messages. Come see me do some live crazy things, responding. And oh, FYI, I'll be using some Azure functions in there, so you don't want to miss. I think Shout out to Microsoft Care Ghana. I think they're going to be there to stream. So if if you happen to not get an invitation, or you actually missed it, you can check the stream on Microsoft Care Ghana's website. Um, Great job. Thanks for supporting the community, guys. We really appreciate it. So this is what we did last week. We just modified a very basic function, and all it did was it takes your name. If I open the test here, it just takes your name, and then it just outputs hello and then calls it. So if I do this, let me just call this, and then I put a name here and I say Sami, and I run this. Takes a bit of time because I'm using all my streaming powers to stream right now. Oh, okay. Yeah, so let's see. Did we change this? Pa, 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 pa. String in the request body. Yep, 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 yep. So let's do this, and let's run this again. Run, 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 run. And there we go. Okay, let me get the functions URL. Let me open this, go to a different tab. Let's paste this here, and then I'll do question mark and then name, and I'll call this Sami. Okay, so if I should zoom in here a bit, so this is it. So if you go to this endpoint, if you go to this endpoint and you just pass your name, it's going to return your name and then provide you with some a random number or a token. So if I run this again, you realize that it's randomized, 72 randomized. Yeah. So this is what we did last week, and today I elaborated and shown you how functions work, giving you an a quick theory of what functions are. Next week, we're back into full force. We're going to continue coding. I'll show you how to set up your local environment. I'll show you how to set up your Visual Studio. And then we'll start writing some functions. Now, if there's a particular thing you want to see, especially in functions, or particular code or piece of logic you want us to write, make sure that send it to me. Any of my handles down here. I will get it and I will respond to you. And then we will take it from there. With that said, I will catch you next week, same time, for some more function fun. But hey, remember, Sundays, 8 p.m., 1 hour, we go deep dive into crazy things. So this weekend, I'll show you how to set up some things. We're going to do some quick coding. I'm going to show you how to add node packages to your functions. I'll be doing some project that I'll share. I think if you look behind me, you see there is a siren light. And I'm sure you're wondering, what is a siren light doing there? Yep, that is just to give you a glimpse of the cool things that's going to happen on Sunday and also on Tuesday. To whet your appetite, check this out. If you want to see more of this and the craziness that's going on, make a day with me this Sunday and next Tuesday. Until then, this has been yours truly, Samuel Adrani, bringing you another episode of Functions Friday. Make sure you learn something a day. Learn, and share. If there's anything you want to know about technology, especially on the Microsoft Azure Cloud, or anything IoT, or anything technology, just get in touch. Send me a message, tweet at me, send me just connect with me, and then I will help you get there. Until then, have a blessed evening, stay safe, and enjoy the rest of your week.